A new idea and we want to get it onto the car, there's usually a gestation process. So we start off with the idea itself, the most important part. It'll then be ranked. We've got to make sure that the intellectual property, if it's a new idea, is protected, so we'll file a patent, for instance, on that. We might engage our supply base to look at different alternatives. We set the specification for the supply base, so we have to make sure that the part will interact properly with everything else in it. We'll have to meet all of our standard criteria, for instance, for heat, humidity, durability, that kind of thing. We then will get through a process where, for instance, we might use computer analysis to make sure that it operates in the correct way. And then finally, when we actually get maybe some prototype parts, we'll run through a series of tests to make sure it works not only as a component, but also on the vehicle as well. And then finally, we'll take it through onto a program, put it through the production process, and put it into sale. With a Jaguar, we've got something that's got a long, sleek bonnet, and we want to try and preserve the dimensions and the proportions of the vehicle. If you build in a passive system into the vehicle, it means that, if you can imagine, the header rail will have to come up, and then therefore to keep the proportions, the vehicle's got to then become wider. So to keep the essential Jaguar DNA, it was imperative we looked for an alternative solution, and that's what we did. We looked for a pedestrian deployable bonnet system. So if you've got a new idea and it comes into the business, all new ideas are accepted on their own merits. It's normally for a particular issue, not always, but there's usually a problem that needs to be solved. At any stage of the process, from first idea right the way through to implementation on a vehicle program, it's always questioned in terms of its validity. So for instance, something better might come along that replaces it, or we might get something from a supplier that does several things, that several ideas that we've come up with might do in one package. So if you look at any component on the car, there's generally about three requirements. One, legislative, like for instance emissions, so we have to do something. There's competitive, so other people in the marketplace have done something that we have to keep up with. Or innovative, in as much that we want to delight the customer and do something that's different that other competitors don't do. If you look at the XK production line, it's a fantastic facility. It's the body in white and the trim and final, so the entire vehicle is made there in one facility. It's a brand new facility. If you look back at the PD process, we've made sure that each of the components and all of the systems fit together using solid modeling. So we've gone through virtual builds already to make sure that the vehicle is as good as it can be before it reaches our colleagues in manufacturing. When you finally get there, there's all kinds of other things to take into account. For instance, the XK is an aluminium vehicle, so we have to think about the recycling effect of that to make sure the different grades of aluminium are recycled into different buckets, control the environment, make sure that we have stable temperature, etc. And it's an impressive facility to look around. I suppose it was the fascination of how things work as a small child. I was probably one of those slightly annoying kids that take things apart and can't quite get them back together again. I have improved now. I grew up in Scotland, so I did Highers, not A-levels. So I did 6 Highers, including maths, physics, obviously, which are most benefit for engineering. Everybody forgets about English. It's really important to be able to communicate your ideas and methods and opinions in as succinct a way as you possibly can. I decided to do engineering as a degree. Did aeronautical engineering at Glasgow University. Once I completed that, I decided to do a further degree, a master's degree at Cranfield University. After leaving Cranfield University, I moved to a small company that was an offshoot of Norton Motorcycles. It was a small company that produced unmanned air vehicle engines, and I worked there for about 6 months before moving to Airbus and moved into the undercarriage development group. I'm the Principal Technical Specialist for Pedestrian Safety, so I work with a small team. I've got about 3 or 4 guys working for me, and we own all of the components that go into the pedestrian deployable bonnet system. So we create the specifications for the suppliers, and we bring all of the components together, make sure that they work in computer analysis, and then actually test them on a vehicle as well. So Jaguar, being a premium brand, is a fantastic company to work for, in as much that engineering's always been thought of as being a bit slightly fuddy-duddy, with sort of like people with spanners working on large nuts and bolts. But you've got that PR launch at the end of the vehicle program, and I've been involved in that, and that's quite exciting. Working at Jaguar is pretty exciting at the moment. We're going through a big change in terms of the model lineup, and one of the great things is being able to drive the cars 12 months before any of the journalists like Jeremy Clarkson or whatever. So when they finally get into the car and give their opinion, you've known what the car's been like for a long time. So obviously you can't really say too much about it to anybody else, but it gives you a good buzz knowing that you've been part of the development process and contributed to what looks like a fantastic vehicle. It may even get to the stage where we begin to develop even more complex models that will look at actual humanoids as well. So we'll actually develop detailed models of how the human body will react in certain conditions, and we'll be able to look at a much bigger span of detail than we can at the moment.